Hi friends, welcome to GMK tutorials. In this video, we are going to discussing about the why nMOS transistor allows a zero voltage without any degradation and why which produces a degraded output in case of the nMOS transistor. So let it be see. Okay, so this is a nMOS circuit. Okay, every nMOS transistor is also having a gate terminal, source, and a drain. Okay, so this is all of you having we know that generally. So let us see that suppose this nMOS transistor is only on for it is activated or the current is passing when the gate to source voltage is greater than threshold voltage. At that time only the corresponding transistor is nMOS transistor is on condition, right? So from this, let us see the situation. See the some situation like if you are treating a nMOS transistor like this is nothing but a gate terminal, source, drain. Suppose if you are applying the gate voltage Vg is equal to 5 volts and the source voltage across the source is also 5 volts, what happened? So this is also 5 volts, this is also 5 volts. Suppose we know that generally the corresponding nMOS transistor is only on whenever the gate voltage is greater than source voltage only, right? This gate voltage is greater than source voltage generally, then only this nMOS transistor is in on condition. Suppose if you are observing this scenario also, here also same thing. Source, drain, gate, we are applying the positive voltage like this. So positive, this voltage is compared to the source is greater than, then only corresponding nMOS transistor is in on condition. That means if both are 5 volts means that obviously what happens is that so gate is also 5 volts, so source is also, that means equal potential range. That means it is not possible to activate the corresponding channel between the source and drain. ఎప్పుడైతే nMOS ట్రాన్సిస్టర్స్ లో గేట్ వోల్టేజ్ అనేది సోర్స్ వోల్టేజ్ కంటే తక్కువ ఉంటుందో అప్పుడు ఛానల్ ఎగ్జిస్ట్ కాదు. కంపల్సరీ దిస్ ఇస్ ద మినిమం క్రైటీరియా. గేట్ టు సోర్స్ వోల్టేజ్ ఇస్ కంపల్సరీ గ్రేటర్ దాన్ థ్రెషోల్డ్ వోల్టేజ్ అయితేనే nMOS ట్రాన్సిస్టర్ ఆన్ అవుతుంది. ఇక్కడ ఎప్పుడైతే క్రైటీరియా సాటిస్ఫై కాలేదో it is not possible to activate the corresponding nMOS transistor. But one of the beauty of the nMOS transistor is that whenever the nMOS transistor, in case of nMOS transistor, it automatically changes the corresponding source and drain terminals. So here drain voltage is 0, let it be considered like this. Okay, at this situation 0 voltage. Okay, therefore when it is changes from gate to source or interchanged means this is nothing but a drain terminal, it is nothing but a source terminal, it is nothing but gate terminal. Now it is a 5 volts region, it is also 5 volts, it is nothing but 0 volts. So from this diagram, gate voltage is 5 volts and source voltage is 0. That means this criteria is satisfied. Gate voltage is greater than source voltage. Therefore, the nMOS transistor is in on condition. So if it is on means that obviously it requires 1 voltage. That means in case of the nMOS transistor, మనకు ఆన్ అవ్వాలంటే minimum criteria అంటే 0.2 of VDD threshold voltage substitute చేయాలి. అంటే that condition must be satisfied. 0.2 of VDD means VDD voltage is equal to here 5 volts. Therefore 1 volt. అంటే ఈ gate voltage లో 1 volt is required for the threshold voltage and remaining voltage will be present across the source terminal. Therefore it produces the 4 volts. This 4 volts is nothing but, so whenever the corresponding source terminal is greater than 4 volts, what happens is that obviously both are equal. This source and drain terminals are both are equal. At that time the corresponding nMOS transistor is again is in half condition. Okay, ఇక్కడ మనకి suppose 4 volts ఉంది అని assumption తీసుకున్నాం అంటే let it 5 volts so 1 volt for threshold voltage, remaining 4 volts will be appear like this. సో ఎప్పుడైతే 4 volts కంటే క్రాస్ చేసిందో ఆబ్వియస్లీ ఈ nMOS ట్రాన్సిస్టర్ లో గేట్ అండ్ సోర్స్ టెర్మినల్ బోత్ ఆర్ ఇన్ అగైన్ ఇన్ ఈక్వల్ కండిషన్. సో ఎప్పుడైతే గేట్ అండ్ సోర్స్ ఆర్ ఇన్ ఈక్వల్ పొటెన్షియల్ అగైన్ nMOS ట్రాన్సిస్టర్ ఇస్ ఇన్ హాఫ్ కండిషన్. సో దట్ ఈస్ ద basic reason why nMOS transistor is produces a degraded output. Okay, so that is a situation, right? So from this diagram, nMOS transistor produces a gate to source voltage. This is drain, this is no. Therefore, it is a chain of reactions. If you are connecting like this for pass transistor logic, again it is a 5 volts region. Again we are getting here 5 volts, 5. This is also 5. Now it is connected to the one more transistor. What happens is that again this voltage, 4 voltage is an input for this one. Only 1 volt is required for the threshold voltage Vt. Okay, therefore 4 minus 1 is equal to 3 volts will be applied. So this 3 volt is applied as input for this one. Again 1 volt is required for the threshold voltage. Remaining 2 volts will be there. So this is nothing but a pass transistor logic family actually. If you are connected in this fashion, it is a pass transistor logic family configuration. Okay, this is a scenario, right? So that's why obviously the voltage drop will be takes place. This is generally called as a multi voltage threshold drop. Multi voltage threshold drop, multi voltage, multi threshold voltage drop, or multi threshold voltage drop, actually multi threshold voltage drop, right? I think it is clear, guys. Okay, so actually this is a basic representation. Actually, if you want to represent the nMOS transistor very strictly, this is a scenario. It can be represented like this. nMOS can be represented like this: gate, source, drain. For our analysis, I can represent. So one more terminal will be here like this. So this is a scenario by nMOS transistor. But coming to the nMOS transistor point of view also, it allows the zero voltage without any degradation. So let us see the situation here. Suppose if you are taking a nMOS transistor, gate voltage, sorry, this is nothing but gate voltage, source, drain. If you are treating it as a 5 volts and input can be treated as a 0 volts, gate voltage is greater than source voltage, nMOS transistor is on, obviously this output is equal to 0 voltage after certain time. That means this nMOS transistor produces the 0 output without any degradation. We don't require any kind of the uh, input voltage here, because of it produces directly input is directly passing through this one. After a certain period of time, the output is going to be 0. So that is a condition, right? So that is nothing but why nMOS transistor produces a degraded output.